Today we're going to discuss the use of synthetic division in getting the quotient and the remainder of polynomials. No? So we have three problems here and then one application. So for the first one, we have 5x cubed plus 8x squared plus 7x plus 4 divided by x plus 1. So this one will be solved by using the synthetic division. No? So first, we want to make sure that the exponent of these polynomials is in the decreasing order. No? So we have here, we just use the coefficients of each term. So we have here the leading coefficient to be 5, the next one is 8, the next one is 7, and the last one is 4. And then we change the sign of the divisor. So if this is positive 1, make it negative 1. And then to start using this synthetic division, we'll bring down the leading coefficient 5, and then we'll multiply 5 by negative 1. So we have here negative 5. So 8 minus 5 is 3. And then multiply 3 by negative 1. 3 times negative 1 is negative 3. And then we add, we get 7 minus 3 is 4. Multiply again by 4. We get negative 4. And then 4 minus 4 is 0. So we get here, to get the final answer, we decrease the exponent of the given polynomial by 1. So this is x cubed. We make this one the first term, 5x squared, and then 3x plus 4 with no remainder, because 0 is our remainder here. So that's it. We have another sample here, 2x to the 4th plus 7x cubed plus x plus 13 divided by x plus 3. If you will notice, we got no coefficients for x squared. So we're going to supply the coefficient of x squared by 0. So we now have a complete decreasing power of this polynomial. So we have here 2, 7x cubed, 7, and then the x squared is 0, plus 1, plus 13, And then we change again the sign of the divisor to negative 3. And then we bring down the leading coefficient 2, multiply it by negative 3, so we get negative 6, and then add, we get 1. Multiply again by negative 3, we get negative 3, and then add, we get negative 3. Multiply again this negative 3 by negative 3, we get positive 9, and then we add, we get positive 10. We multiply again this positive 10 by negative 3, we get negative 30. And then when we add, we get negative 17. And then we decrease the answer, the coefficient of, or the exponent of the leading coefficient to 1. So if this is 4, x to the 4th, the first term is 2x cubed plus x squared minus 3x plus 10. And so this last term here, the constant, is our remainder. This can be written also by negative 17 over its divisor x plus 3. So that's okay. That's the same. So for number 3, we have 2x cubed plus x squared minus 18x plus 7, you divide it again by negative x minus 2. Similarly, we just copy the coefficients. So 2x negative 18 plus 7, and then we change the side of the constant of the divisor to positive 2. From negative 2 to positive 2. And then we bring down the first, or the leading coefficient 2, and then multiply it by 2. We get 4, then add, we get 5, 1 plus 4. So, multiply 5 by positive 2, we get 10. Add, we get negative 18. And then we multiply negative 8 by 2, we get negative 16. Then when we add, we get negative 9. And then we subtract 1 to the exponent of the given problem or polynomials. We have here 2x squared 5x minus 8. So the last term is minus 8 2x squared minus x. So and the remainder is negative 9, no? So that's it. That's how we're going to use synthetic division in solving the polynomial division. No? We have now one application problem here. It says Ray traveled the distance of 6x squared minus 13x minus 5 kilometer at the rate of 3x plus 1 kilometers per hour. We write a polynomial that represents the number of hours traveled. Since we know that the formula for rate is equal to distance over time, to find the time, no, it's equal to distance over rate. So distance over rate, since the distance is given as 6x squared minus 13x minus 5, so we divide it by 3x plus 1. So again, we're going to use only the coefficients of its term here. So 6 minus 13 minus 5. But the given divisor is 3x plus 1. Take note of this, no? So if this is 3x plus 1, we divide this 3x here by 3 and also this one by 3. So we get 1/3. And then change the sign of this divisor here. So we get negative 1/3. So in doing the synthetic division, we again bring down the leading coefficient 6, multiply it by negative 1/3, we get negative 2. We add, we get negative 15. And then when we multiply negative 15 by negative 1/3, we get 5. When we add, we get 0. No? So this is 0, cancels out. So our answer is 6x minus 15. So this will be our answer for the number of hours. The total number of hours is equal to 6x minus 15. So that's how we're going to use the synthetic division. I hope you learned something. And again, please be, after this, subscribe to my YouTube channel and then click that notification bell. Thank you and see you later.